Welcome back to our final video. This one's on horizontal stretches and compressions. Let's go ahead and get started. So for starters, I've already graphed our equation, which is our original function, which is f of x equals the absolute value of x, and I filled out the table. So if you need to take a moment and pause the video and fill in that information, then go right ahead because we're going to go ahead and jump right in. So this time we're following the rule h of x equals f of 2x, which is a little different. So let's see what happens. So when I plug in h, and I'm going to plug in -2 here, and following that rule, f of 2 times -2, well, 2 times -2 is really just -4. So I really have f of -4. And the absolute value of -4, because I can plug that into here and figure out what that is. So the absolute value of -4 is +4. So our new coordinate is when I plug in -2, my output is 4. So -2, 4. Okay, let's do the next one. So I have h of -1 equals f, and then 2 times -1. 2 times -1 is -2, so f of -2, and I can use my table for this one. So when the input for f is -2, I'm going to look right here, then the output is +2. Okay, so my new coordinate here is -1, 2. So let's go ahead and plot it. So -1, 2. Okay, h of 0. So f of 2 times 0. 2 times 0 is just 0. So f of 0, and we already know that that's 0 because we're doing absolute value. 0 is 0 away from 0. Say that 3 times fast. 0 is 0 away from 0. Okay, next one. H of 1 equals f 2 times 1. So 2 times 1 is just 2. So this is really just f times f of 2. And f of 2 is just 2. So here our coordinate is 1, 2. And then our last one, we're going to plug in 2 for x, following the rule. So 2, and then plug in that other 2. So 2 times 2 is 4. So I really have f of 4. And the absolute value of 4 is just 4. So my new coordinate here is 2, 4. And I can go ahead and plot that. And I don't know why that went away. So now I've got my new graph in green, and we're going to call this H. So I'm going to go ahead and skip the domain and range part really quick because I want to talk about what that 2 inside our parentheses / inside our function did for us. So this B, or that 2 that we were using and multiplying over and over and over again, what that ended up doing is that ended up being a horizontal compression. So its immediate impact was on the input, and we can kind of see that here. So here was our input, and here we see how that rule of 2 inside our parentheses, and when I say inside the parentheses, I'm talking about this. So that's how it affected those inputs. Okay, and because it's a whole number, it's greater than 1. I feel like a lot of us would think that it's a stretch, but it's actually a compression. So this point got compressed inward, this point got compressed inward, and same on the other side. That point got compressed inward, and this point got compressed inward. Now, if we had something like m of x equals f of 1/5 of x, well, this would then be a horizontal stretch. Okay. And if we go ahead and do the domain and range, well, we know that our domain for the original graph, which is our f, I'm writing it in blue, they told us our domain is from -4 to 4. Our range was from 0 to 4, those values included. And then for our h graph, so our domain for the h, I see that our domain expands from -2 to 2. Okay, and we can see this compression in our domain as well. Our range ended up staying the same, so that's from 0 to 4. But we can really see the compression take place in our domain. So our domain for our F graph is -4 to 4, and our domain for our H graph, after following that rule, is from -2 to 2. So it got compressed. It got cut in half by a factor of 2. Okay, thanks for watching.